Okay, now we will look at and analyze the results for each model. The first model we have is regression. It shows that we had one very strong independent variable, and that was the expenditure on primary education as a percentage of expenditure on education. We also had two decently strong independent variables, the GDP per capita and the repeaters of primary school for our grades. All other variables were negligible. Our second model is neural network, and as you can see from the chart below, some of the variables are stronger than others, but all of them play a part in predicting the dependent variable. Our third model is linear regression. You have one dominant independent variable, which is the repeaters of primary school for all grades, and then two decently strong independent variables, staff compensation as a percentage of total expenditure on primary institutions, and GDP per capita. All other variables were very weak or negligible. Now, comparing and assessing the models. Our model of choice that we think best describes the current situation is a neural network. We looked at this in two manners. One is subjectively, um, which is more opinion based. The regression and linear regression determined that certain independent variables to have a negligible effect on a dependent variable. For example, labor force of primary education and out of school children of primary school age and percentage of teachers in primary school who are trained. So basically the regression, linear regression, told us that it didn't matter whether or not the teachers are trained. That didn't have effect on the enrollment rates as well as the labor force of primary education, and that is something that, subjectively speaking, we're not totally comfortable with those results. Now, objectively speaking, both regression and linear regression determined that GDP per capita had a very strong effect on the dependent variable. And then both regression and linear regression also determined that expenditure on primary education as percentage of total government expenditure on education was negligible. So what that means to us is that the the factor that determines how much much money the government makes, the GDP per capita, it exemplifies how much government makes, is very strong. However, the factors such as the one given here that determine that show us how much the government spends on education was negligible or very weak. The problem we see with this is these models were telling us that if the government makes, great amounts of money, that it has a strong effect, but it doesn't matter whether or not the government actually spends this money on education. So if you have a country, for example, that makes, brings in strong income through taxes on the GDP, but spends none of that income on education, instead decides to buy fighter jets and tanks, then by those two models, regression and linear regression, it should have a high enrollment rate in primary education, and that is also something that we had some issues with. As a summary to the presentation, we utilized data that was made public by the World Bank. We created three models for understanding factors relating to primary school enrollment rates. Of those three models, the neural network was the best model, both subjectively and objectively. And some of the lessons learned from this is that, one, societal factors play a role. Things such as adult literacy rate and labor force with primary education. As we saw from the neural network, they play a role in determining primary education enrollment rates. Economic factors play a role, such as GDP per capita, which is this representation of how much money the government is bringing in through taxes on GDP. That plays a role, but also governmental factors play a role, which is the government spending on education as a percentage of total government spending. So not only is it important how much money the government is bringing in, but also how much money the government is spending on education.